So if you remember from yesterday, the entire goal for these problems is to simplify the expression. Right now, the expressions are in their rational expressions, so they're fractions, and the numerators and denominators are both polynomials. And in order to simplify any expression, the first thing you're going to want to do is factor that expression. So in letter E, I see x cubed minus 16x on the top and x squared minus 2x minus 8 on the bottom. Your first step in solving these problems to simplify will be to factor. So I'm just going to write on the side, step 1 is going to be to factor. So I'm going to factor the numerator and denominator in hopes that I can cancel things out. When you have the same thing in the numerator as you do in the denominator, they do cancel out. So that's your whole plan. In letter E, it's a little bit different than the problems from yesterday. Like yesterday, I feel like a lot of the rational functions had binomial over binomial, meaning they're just like one single term with a lot of things. These look a little bit different. Like as soon as I see the numerator x to the third power minus 16x, I realize that this one looks different. I see that they share a common factor of an x, so the first thing I kind of want to do is just take the x out of x to the third power minus 16. Sorry, I forgot to change this to x squared. X times x squared minus 16, just to see if that helps at all, because sometimes when you're factoring things, you might not necessarily be factoring each part completely, because your goal is to cancel everything out that can be canceled in the numerator and denominator. So once I go to factor the numerator, I also am thinking, okay, x squared minus 16 can be factored further. X squared minus 16 is called a difference of squares because x squared is a perfect square and 16 is a perfect square. It's also considered a trinomial with the middle term, the b term, being 0, like x squared plus 0x minus 16. So x squared minus 16 can actually be factored further into x plus 4 times x minus 4. So altogether, the numerator of this fraction factors to be x times x plus 4 times x minus 4. So I factored that right here. So I'm going to factor the denominator over here, I guess. I have x squared minus 2x minus 8. And to factor that, this is a trinomial. I can see all three terms, the x squared, the x, the negative 8. I can't take any GCF out. I can't take an x from everything. I can't take a number from everything. So automatically, since I see that it can't be simplified with any GCF, my next step would be to factor using the trinomial method. What multiplies to be negative 8 and at the same time adds to be negative 2. So what multiplies to be negative 8, you're going to have one positive and one negative. And the factors that will do this will be 4 and 2. You just have to make sure you're putting the right number, the right positive with the right number. In order to get a negative 2 as my answer, when I add them, the 4 will have to be negative. So I'll need x minus 4, and I'll need an x plus 2. So now that I have factored the numerator and denominator, let's put the function, let's put the expression back in its spot with the numerator being now factored as x times x plus 4 times x minus 4, and the denominator being x plus 2 times x minus 4. So I factored both the numerator and denominator. So I guess I should write that for step 1. Factor numerator and denominator. And then once everything is factored, the second part will be to cancel anything that's the same in the numerator and denominator. So now it's for the cancellation step. So in order to cancel things out, the expressions need to be in factored form, because when you have a fraction that is in factored form and everything is being multiplied, you can cancel the same thing in the top as it is in the bottom if it's identically the same. So there's only one thing that can cancel, because there's only one thing that's identically the same in the numerator and the denominator, and it's the x minus 4 here and the x minus 4 here. It does not have to be directly over top of each other. If you had x minus 4 in the very beginning of your factored form on the numerator and the x minus 4 at the very end, as long as you have one at the top, one at the bottom, they will cancel out. And then you will be left with the final answer in simplified form. This would be x times x plus 4 over x plus 2. That would be the simplified rational expression for letter E. All right, the next one is now randomly number 5, and it is kind of similar in nature. Same kind of process I feel like is going to happen for that problem there. So why don't you try number 5? I'll give you a few minutes to get started, and then I'll go over the answer with you shortly. All right, so for number 5, we're going to follow the same process here. I'm going to just use green for this one and erase this stuff that I took this space from. And I'm going to factor the numerator and denominator separately. So here's my numerator, x to the 3rd power minus 4x. As soon as I see this one, I see that they share a common factor of x. So again, I'm going to try and take this out, and I'll be left with x times x squared minus 4. And then once I do that, I can see it better that this can be factored further. X squared minus 4 is considered a difference of squares since they're both perfect squares. The square root of 4 is 2. So 2 times negative 2 equals negative 4 and also equals 0 when you add them. So this can be factored completely into x times x plus 2 times x minus 2. So that's your numerator factored. The denominator factored, x squared minus 5x plus 6. What multiplies to be 6 at the same time adds to be negative 5. Well, the only way you can ever take two numbers and add those two numbers together and get a negative and at the same time multiply those two numbers and get a positive is if they're both negative. So these factors would be x minus 3 times x minus 2. So once I put this back into its rational expression form, in factored form, this will be x times x plus 2 times x minus 2 over x minus 3 times x minus 2. When you're canceling things out, you can only cancel pairs of things that are identically the same in the top and bottom. So what's the thing that can cancel out in this problem? Yep, the x minus 2 cancels here and here. So the final answer in simplified form would be x times x plus 2 over x minus 3. That would be the simplified expression for the original problem there. And remember, these questions are just asking you to simplify, which is different than what we did before. Before was finding the domain, which would then make the denominator equal to 0. So different questions with the same types of problems. Now this last one here is definitely a challenge, so we're going to do this one together, and then the last problem on the page is a challenge as well. So we're going to go through these two application problems together before we take the rest of the class to practice. So here's the challenge problem. The first step in solving these, or simplifying these I should say, is factoring both the numerator and the denominator. So I'm just going to rewrite the numerator over here. I know my first step is going to be to factor this, and then my second step is going to be to factor the denominator, so I'll write this over here. So for these problems, you're going to have to factor now 2 problems per each individual problem since you have now numerators and denominators. So as soon as I see the numerator problem, I realize here's why they said this is a challenge, because this is not easily factored. And that's because this number here is not a 1. As soon as this number is anything but a 1, we have to factor the long way, which means I have to figure out what a times c equals, so what 2 times negative 5 is, and a times c is going to be negative 10, and b is 3. So I have to find the factors that multiply to be negative 10, and at the same time add to be 3. So I can get a negative 10 from 5 and 2, and I can get a positive 3 to add if I have a positive 5 and a negative 2. So these are going to be the pairs of factors that I would need. And what I do from there is split up the middle term into 5x and negative 2x. So I basically take the trinomial and make it into a 4-termed polynomial with this process. And that's because the original a number is not 1. And this happens every single time. So I'm going to expand this problem. I'm going to erase this stuff since I now found it. I'm going to expand this problem into 2x squared plus 5x minus 2x minus 5. Now notice, if I was to simplify that, 5x minus 2x is 3x. So all I was really doing was just splitting this up into 4 terms so that I can do this type of factoring, which is factoring by grouping. Factoring by grouping is going to be needed to be used every time the leading coefficient number here is not 1. So factoring by grouping means draw a line down the center and factor each side separately. And when we factor each side separately, you're factoring from the GCF. So 2x squared plus 5x, the only thing I can take out of both of those terms is an x, and I'm left with 2x plus 5 when I do that. And then on the right-hand side, as soon as you see this number being negative here, so since this is a negative, I know I need to factor out the negative. You never want to have a leading number be negative. So I'm going to factor out a negative in order to get the inside parenthesis numbers to match. And because negative 2x minus 5, they don't share any common numbers, like they don't share a factor of 2 or a factor of 3 or anything like that, then the only thing you can take out is a negative 1. And when you take the factor of negative 1 out, you're left with 2x and plus 5. You can see that what's in parentheses matches. If you ever come to this point and it doesn't, then you should know that you made a mistake. They will always match. And then you can rewrite this in factored form as x minus 1 in one set of parentheses, all times 2x plus 5. So that is my numerator in factored form. I'm just going to circle it for now. I'm going to come back to it. That's not the answer. That was just factoring the numerator. Now we have to factor the denominator. The denominator is not in standard form right now. Standard form for polynomials has the highest exponent first, going all the way down to the constant number. So I need to move things around. This negative x squared needs to be moved to the front. So I'm going to move it to the front here. That's negative x squared. And then the next thing I need to move to the front is the negative 6x and then plus 7. So what I did was I just moved the 3 terms around so that they're in the correct format. The next thing I realized is that the leading number, the leading coefficient, can never be a negative. So see how it says negative x squared? You have to get rid of that negative, so the only way to do that is before you even factor it, factor out a -1, and you're left with x squared plus 6x minus 7. I'm doing that because from the very beginning I explained to you when you're factoring, you can't have a negative number be the first leading number. You're going to want to get rid of that, so I can do that with factoring out a -1. But this still can be factored further. Now we're going to factor the trinomial x squared plus 6x minus 7 into what multiplies to be -7 and at the same time adds together to be 6. So the only factors of 7 are 1 and 7. So, and to multiply to be a negative, you have to have one positive and one negative. So in order for this to work, I would have a +7 and a -1, since 7 times -1 is -7, and 7 minus 1 is 6. So I'll circle this part. This is the factored form for the denominator. Now taking my numerator and putting it back in its spot, and the denominator and putting it back in its spot in factored form, this expression is x minus 1 over 2x plus 5 all over -1 times x plus 7 times x minus 1. Now that everything's factored, now it's time to do the cancellation part. Anything that's the same in the numerator as it is in the denominator can cancel out. So looking at the different factored terms, the x minus 1 in the top can cancel with the x minus 1 in the bottom. So your final answer in simplified form is 2x plus 5 over -1 times x plus 7. Now notice, I did get rid of the parentheses around the 2x plus 5. You can leave them there if you would like. You can get rid of parentheses if you only have one factored term left, but you can still leave them. I had to keep the parentheses around the x plus 7 because obviously there was more than one thing in the denominator, so you would have to keep those there. So this would be your final answer after all of that, factoring the numerator, which took time, factoring the denominator, which took time, canceling it out, and then here's what you're left with. And then the last example is an application problem. These types of problems are definitely the ones you're most likely to see on our next quiz and test. And this application is asking us to find the ratio, that means find the fraction of the shaded portion to the total area of the figure. Okay, so the ratio means fraction. And the first thing that, as soon as you see ratio, the first thing that's said is going to be the numerator. So this is going to be the numerator, and the total area of the figure will be the denominator. Okay, so we need to find the both of the areas separately. We need the shaded portion area, and we need the total area from this figure. So I'm just going to label this. This is going to be the shaded and then the total area. Well, thankfully, these are just rectangles. The area of a rectangle is simple. It's length times width. So the shaded region is going to be this middle part right here. And this is just x. I don't need a parenthesis. This is just x times x plus 1. I'm going to leave the area in factored form since what we're going to be doing is simplifying in the end. So I'm going to leave it just like that. Previously, in previous sections, you would have multiplied this out to put it into standard form, but I'm going to leave it in factored form. That factored form represents the area of the shaded region. And then the total area would be what times what? Perfect. X plus 1 times x plus 3. Now they say find the ratio of the shaded portion to the total area. That means the shaded portion will be on the top and the total area will be on the bottom. Okay. Now, technically the directions should say simplify because that's what we're doing in this section. But this is the ratio of the shaded portion to the total area. If this question just said that, you could technically be done. But I would want the directions to say, find the simplified ratio of the shaded portion to the total area, which then would require one more step. What's the last thing you could do after you put it into its place to simplify it? Sophie? I just can't hear you. Yes, we can cancel out these x plus 1's here, and we'll be left with the simplified area as x. That's the only thing that's left on the top, over x plus 3. That's the only thing that's left on the bottom. This is simplified. This is what I would be looking for in the end. But this, what we found here, this is the ratio that compares the two. So you would need to understand that, and then you would need to simplify.